Hi viewers, this is Dr. Jana and you are watching video with me on machine learning. In our part 1 or the first part of this machine learning video, we covered what are the fundamentals of the machine learning, the different type of machine learning algorithm, and after that we studied the supervised, unsupervised and reinforced learning. The supervised learning we divided into two categories. One is the regression and another is the classification. Now we are in the supervised learning and we are in the regression part. So this regression, we have two type of regression. One is the linear regression, then is the multiple regression. Let us focus on this linear regression. The linear regression algorithm, it shows a linear relationship between the dependent variable y and the independent variable x. Hence, we call it as a linear regression because there exists a linear relationship between them. Linear means it should be represented by a straight line. And the model provides a sloped straight line, you can see. But actually, while you are going for the scattering plot, the data points will appear here and there. Then we fit it into a line, a sloped line, which is called the linear regression. Clear? Now, this line is represented by the equation y is equal to a0 plus a1x plus epsilon or whatever you say, another a2, that is the residue, whatever you say. See, y is the dependent variable or the target variable and x is the independent variable or the predictor variable. A0 is the intercept here to the y-axis or some axis, and a1 here, a1x, a1 is the linear regression coefficient or the scale factor, then epsilon is the random error. So these are the things we studied. Now we are going for the linear regression in detail. The linear regression is one of the most popular and simple machine learning algorithms that it is used for predicting analysis. Here, predictive analysis defines predictions of something and linear regression makes prediction for continuous numbers such as salary, age, etc. Salary, it will be 1000 rupees, 5000 rupees, 10,000 rupees, like that. Age 35, 38, 39, whatever things are there. So it shows the linear relationships between the dependent and independent variable, as already discussed, and is represented by the equation. Here a0 is the intercept, a1 is the your linear thing, it is the coefficient, okay, then b the residue. Now the first part of these things is the simple linear regression and the second one is the multiple linear regression. In the simple linear regression, here a single independent variable is used to predict a single dependent variable. Here, for example, I want to predict the salary, that is the dependent variable, based on the experience. Here independent variable is only experience and the dependent variable is only salary. And both the cases, these are numerical values. Okay. So in this case, this is the example of simple linear regression, and here we are going to predict using like these things. And here you are using one linear regression line. You see all these data points are here and there scattered. Then we fit it to a line. This line I call it as the linear regression line. So a linear line, this is showing the relationship between the dependent here variable and the independent variable here. So this relation between that is represented by this line. We call it also the regression line. So regression line can be of two types. So two type of relation. One is the positive linear regression, positive linear relationship. Another is the negative linear relationship. In the positive linear relationships, the values in the y-axis it grows. If it is growing like this, we say it is positive line of regression, the predicted value. But if the predicted value is decreasing like this, in this way going down, so this is called the negative linear regression or relationship. It's clear? Now we need to find the best fit line. Why? Because if you see the data points are scattered, So with this scattered point, we will be unable to predict for the test data. Then what we need to do? We have to find the best fit line. So our main goal is to find the best fit line. That means the error between the predicted value and the actual values should be minimized. Clear? So you seen the predicted line is there, the straight line or the sloped line, and the actual are something different, that is scattered here and there. How do you achieve that one? We achieve it, that means if you minutely observe, each and every line is having a different slope and also having some intercept a0 and also the residual, that is the difference between the actual and the predicted. So now we can draw a number of lines, and after the best one, it is optimized one, we want to take it as the regression line. Then for that, what we need to calculate? We need to calculate what is a0, a1 and a2 like this. So this is calculated using the cost function. Okay. Then what is this cost function? The different values for weights or coefficients of lines, the coefficients like a0, a1, and gives the different line of regression, and the cost function is used to estimate the values of these coefficients for the best fit line. That is the idea. So and these cost function are fine, so they improve the accuracy of the mapping function, and this mapping function is also known as the hypothesis function, right? Now for linear regression we use the mean squared error or MSE cost function. What is that? Let us see. We have a formula to calculate the mean square error. MSE is equal to 1 by n into summation of I is equal to 1 to n yi minus a1 xi plus a0 like this. So this a1 xi plus a0, this is the predicted value, because using the straight line we are going to predict, and yi, this is the actual value, actual output. Okay. Now what is the residuals? The distance between the actual value and the predicted values is called the residuals. These observed points are far from this regression line. If the observed points are far from the regression line, then the residual will be more or high, and so cost function also will be high. Now our job is to reduce this cost function. Okay, that is the thing. This you can see the simple linear regression. We are going for the salary versus experiences during the training data. So it is coming like that. While we are going for the test data set, so it will be shown like this. Now we are using this gradient descent to minimize the mean square error. So this is done by calculating the gradient of this cost function, and a regression model uses the gradient descent to update the coefficients of the line by reducing the cost function, and it is done by random selections of values of coefficients and then iteratively updating the values of values to reach the minimum cost function, and it also improves the performance, so model performance. The goodness of fit determines how the line of regression is fits the set of observations, and the process of finding the best model out of various models, it is called the optimization. It's clear? Then we use the R squared. This is a statistical method that determines the goodness of fit. So it measures the strength of the relationship between the dependent and the independent variable, and represented with a scale of 0 to 100%. The high value of R square determines the less difference between the predicted value and the actual values, and hence represents a good model. It is also called a coefficient of determinations or coefficient of multiple determinations for multiple regressions. It can be calculated from the below formula. R squared is equal to explain variations by the total variations. Then we go for this multiple linear regression. Multiple linear regression, it is an extension of the simple linear regression, as it takes more than one predictor variable to predict the response value. That means in the x-axis we will have more than one value. Okay. Here some key points or the features of the multiple linear regression is that the dependent or the target variable y must be continuous or real. But the predictor or independent variable may be continuous or categorical. Categorical means some value like true, false, yes, good, no, like that. And each feature variables must model the linear relationship with the dependent variables. Now, the multiple linear regression tries to fit a regression line through a multi-dimensional space of data points. For example, suppose I want to calculate the carbon dioxide emission based on the engine size and also the number of cylinders in a car. So, there we can go for this multiple linear regression. See here, suppose we are having more than x or the independent variables, one is x1, one is x2. You see, if you plot x1 is also increasing, it is not simply all constants. Here from this point to increasing. Similarly, x2 is also increasing, it is from this point to this point, increasing, decreasing, whatever things are there. And based on this x1 and x2, we are going to predict the y. It's clear. So, here instead of representing by one line, it is represented by a number of lines or by a plane, like that you can see it here. And the data point still it can be above or below, but we forcibly map to a line or a group of lines, that is called the multiple linear line, regression line. It's clear. And this equation is represented using the equation y, which is equal to b0 plus b1 x1 plus b2 x2 plus b3 x3. Here y the output or the response variable, b0, b1 etc. they are the coefficient of the model, and x1, x2, x4 these are the various independent feature variables, okay, or the independent variables. What is the problem description? Suppose we have a data set of 50 startup companies, and the data set contains 5 main informations like R&D spent some amount, administration spent, marketing people spent, state and profit for a financial year. So, our goal is to create a model that can easily determine which company has a maximum profit and which is the most affecting factors for the profit of a company. Now, some of the main steps involved for deploying this the multiple linear regression is, first we go for the pre-processing of the data, then fitting the MLR model to the training set, then predicting the result of the test set. So, this is the thing we go for that one. Then what do we do? Another model we call it as the polynomial model. Why? You see, when the data points are here like this, it cannot be forced or fit to a single line. So, instead we go for a polynomial or just like a parabolic, like that. These things it better describes. So, this is represented y is equal to b0 plus b1 x1 plus b2 x1 square. So, this is not simple, it is some polynomial order degree order is there. Now, with this we covered the different type of regression. Still some other regressions we will study in details. Now, we are going for this classification algorithm. See, the classification algorithm is a supervised learning technique that is used to identify the category of new observations on the basis of training data. In classification, a program learns from the given data set or observations and then classifies a new observations into a number of classes or groups. What is the meaning of that one? Here, the dependent variables are just like some categorical value like yes or no, 0 or 1, spam or not spam, cat or dog, like that. So, in classification algorithm, a discrete output function. So, this is the y will be discrete, is mapped into the variable x. Clear? So, y of x, y is a categorical value. So, what is the categorically? It is yes or no, it is a spam or not a spam. Okay, all the things are there. Then the algorithm which implements the classification on a data set is known as the classifier. We are having different type of classifiers, at least two. One is the binary classifier, where we implement like yes, no, male, female, spam or not spam. Another is the multi-class classifiers. Here, suppose you go for the classification of types of crops. So, there are so many type of crops, rabi crops, the cash crops, like that so many crops are there. You cannot say it is only two type of crops are there. So, in those cases we go for the multi-class classifiers. And the classification of types of music, that is also the genre type, the no light music is there, no, all these different musics are there. Then the learners in classification problem, we have two type of learners. One is the lazy learners, another is the eager learner. The lazy learners firstly stores the training data set and wait until it receives the test data set. So here the training time is fast, but prediction takes more time. Example is the KNN algorithm, case based. Another is the eager learner. Here the training time is more, but prediction takes very less time. Example, the decision tree, naive Bayes and ANN. Now the type of machine learning classifications algorithm, we classify into two categories initially, that is the linear model and nonlinear model. Under the linear model we go for the logistic regression and the support vector machine. Under nonlinear models we go for the k nearest neighbor, KNN, then SVM, naive Bayes, decision tree and random forest classification. Then we go for the logistic regression in machine learning. This logistic regression is one of the most popular machine learning algorithm which comes under the supervised learning techniques. But it is based on the predicting the categorical dependent variable. The dependent variable should be categorical. That means yes, no, good, bad, all the things using a given set of independent variables. Now logistic regression predicts the output of a categorical dependent variable. Therefore, the output must be a categorical or a discrete value. It can be either yes or no, 0 or 1, true or false, etc. But instead of giving exactly 0 and 1, it gives a probabilistic value which lies between 0 and 1. So the logistic regression is much similar to a linear regression, except that how they are used. For example, linear regression is used for solving regression problems, whereas logistic regression is used for solving classification problem. If you are going for the classification, then the logistic is better. So other cases you can go for the linear regression. So in this logistic regression, instead of fitting a regression line, we fit an S-shaped logistic function or just like a curve like things, which predicts two maximum 0 or 1. And the curve from this logistic function indicates the likelihood of something, such as whether the cells are cancerous cell or not, or a mouse is obese or not based on these weights, etc. This logistic regression, it is a significant machine learning algorithm because it has the ability to provide probabilities. That what I told, it is vary between 0 and 1, it can be 0.1, 0.2, 0.3, 0.8, etc. And new data using the continuous and the discrete data set. This logistic regression can be used to classify the observations using different type of data and can easily determine the most effective variables used for the classifications. Okay, so from the below image we can clearly understand. Here is a logistic regression. It is varies between 0 and 1. Here are using a concept of threshold value. If it is less than 0.5, it is 0. If it is more than 0.5, it is 10 to 1. So it is more or less, it is equivalent to the sigmoid function. The sigmoid functions what you are using in the ANN, it is a mathematical functions used to map the predicted values to probabilities. It maps any real value into another value within a range of 0 to 1. Now the value of this logistic regressions must be between 0 and 1, which cannot go beyond this limit. So it forms a curve like the S-form, and the S-form curve is also called the sigmoid function or the logistic function. In logistic regression, we use the concept of threshold value, which defines the probability of either 0 or 1. So as values above the threshold treated as 1 and below treated as 0. Now, what are the assumptions in the logistic regression? The dependent variable must be categorical. That means y-axis values must be categorical. The independent variable should have multi-collinearity, and this logistic regression equation also we are having the equation here. Y is equal to b0 plus b1 x1 plus b2 x2 plus b3 x3 plus bn xn. And in logistic regression, y can be between 0 and 1, I told you. So this, let's divide the above equations by 1 minus y. So y divided by 1 minus y. So this is 0 if y is equal to 0, and it is infinity if it is y is equal to 1. If y is equal to 1, 1 minus 1 is 0, something by 0 is infinity. Now but we need a range between, instead of 0 and 1, we need between minus infinity to plus infinity. Then the algorithm looks like this: logarithm of y by 1 minus y, so b0, b1, etc. This is the actual equation for this logistic regression. We have the different type of logistic regression. One is the binomial, one is the multinomial, third one is the ordinal. In the binomial, the dependent variable have some value like 0 or 1, that is pass or fail, etc. In the multinomial, so it can be minimum 3 or more, like cat, dog, sheep, etc. These are things we are going to classify. Then in the ordinal, it is in the increasing or decreasing order. For example, low, medium and high. Okay, so there can be 3 or more possible order type. Clear? Then we go for the data pre-processing in machine learning. Why this data pre-processing is so important? Data pre-processing is a process of preparing the raw data and making it suitable for a machine learning model. It is the first and crucial steps while creating a machine learning model. So without the pre-processing, the efficiency cannot be improved, right? So why do we need to go for the data processing or the pre-processing? A real world data generally contains some noises, some missing values, and maybe in an unusable format which cannot be directly used for the machine learning models. So in the data pre-processing, it is required a task for cleaning the data and making it suitable for a machine learning model, which also increases the accuracy and efficiency of the machine learning models. So these are the following steps it involves. So first we get the data set, then we import the libraries, import the data sets, then find missing data, then encode categorical data into numerical values, then splitting the data into training and data and testing data set, then some feature scaling. So these are the things. Now what about the data we collect either in the XSL or CSV form? That we call the data set, just in a tabular form. So rows will be there, column will be there, some data will be there. The CSV stand for the comma separated values. Then we need to go for the importing the libraries. We are having a number of library files while you are using in Python. So we will be importing these library files. Then some of the files are, some of the libraries are NumPy. This NumPy are the numerical Python, whatever you say. This is for calculation in Python. The scientific calculations, this is a package, we call it the NumPy. Okay. So we do it, import NumPy as this thing. Then we use matplotlib. This is the second library. This is used for the plotting the 2D plots in Python. So then the pandas. Pandas is also a library function which is used for the most famous Python libraries. This is used for importing and managing the data set. So dealing with the data set, we use the pandas. So for the NumPy, use import NumPy as nm. So import pandas as pd. For the importing the data set data underscore set, which is equal to pd. What is that? Because for dealing this data set, we are using panda pd. So pd one use a method read underscore csv. What is the name of the data set? That is dataset.csv or anything, say supermarket.csv, whatever the data in the CSV format, you do it. Then for extracting the features in machine learning, it may be important to distinguish the matrix of the features, that is the independent variables and the dependent variables from this data set. That means which is independent, which is dependent. For example, I want to calculate the salary based on the country and age, something like that. So extracting independent variables, what is the syntax for that one? We use the iloc method. So I first we put data underscore set dot iloc, so colon comma colon -1 dot values, that is assigned to x. Okay, in this above code, the first column what you are using, that is to take all the rows, and the second column we are using, that is to take all the columns, and -1 you are using because we don't want to take the last column as it contains some independent variables. So by doing this, we will get the matrix of features. It's clear. Then extracting the dependent variables, again the same thing. So y is equal to data underscore set dot iloc, so colon comma 3. So here we can get or extract the dependent variables. Then handling the missing data. So the next step of the data pre-processing is to handle the missing data in the data sets. If our data set contains some missing data, then it may create a huge problem for our machine learning model. Hence, it is necessary to handle missing values presented in the data set. So by deleting that particular row, the first way. So just you delete that row because incomplete data, I delete that row. Second, by calculating the mean. What is the previous one? What is the next one? Take the average and put it there. So this is the two way by which we can missing data we can handle. We have some package in the scikit-learn library. For that, what we do? We use imputer classes of the sklearn.preprocessing, and it is clearly given here. So from sklearn.preprocessing, import imputer, and imputer is equal to imputer missing underscore value n like that we go on explaining. Then another technique, it is the encoding of categorical data. Why is so important? See, for example, in our data, some categories such as our data set are there, like the variable country and purchased. Since machine learning model completely works on mathematics and numbers, but if your data set have a categorical values like India, USA, UK, then it may create some trouble while building the model. So it is necessary to encode these categorical values into numbers. So this is called the encoding techniques. For country variables, firstly we will convert the country variables into a categorical data. So to do this, we will use some label encoder classes from the pre-processing library. Here it is given something that from this we can do it like this. But in this case, what we do, there are three countries variables, and as we can see the above output, these variables are encoded into 0, 1 and 2. By these variables, the machine learning models may assume that if it is 0 one country, if it is 1 some country, it is 2 is some country, like that. Then we can use some dummy variables also. Dummy variables are those variables which have a value 0 or 1. The one value gives the presence of that variable in a particular column, and the rest variable becomes 0 with the dummy variable. So using that also, one hot encoder, all the things you can do. So then splitting of the data. So the splitting of the data is very important because we have to train the model. So we divide into training set and also test set. In machine learning data pre-processing, we divide our data set into training set and the test set. This is one of the crucial steps of data pre-processing, as by doing this we can enhance the performance of our machine learning model. Suppose if you have a given training to our machine learning model by a data set and we test it by a completely different data set, then it will be creating difficulties. See, for example, we are training them, it should be a fruit or vegetable, so it is cylindrical or it is something like that, and we provide some drumstick and we ask the machine, you category, under which category it is coming. It will be difficult for it too, because this type of data is not trained, was not available there. So if you train our model very well and its training accuracy is also very high, but we provide a new data set to it, then it will decrease the performance. So we always try to make a machine learning model which performs well with the training set and also with the test data set. Clear? Now the training set, a subset of the data set to train the machine in the learning model, and we already know the output. Test set, a subset of the data set to test the machine learning model, and by using this test data set, model predicts the output. For splitting, we can split into 0.2, that is means 80%, 20% or 70%, 30%, like that. Then we will be using some variables like xtrain, xtest, ytrain, ytest, and for splitting we use this function train underscore test underscore split, this function. So it can be 0.5, 50, 50, 0.3, 70, 30 or 0.2, 80, 20. The last parameter is the random state, that is used to set a seed for a random generator, so that we always get the same result and the most used value is 42, something like that. Then the feature scaling. In this feature scaling, we can it is the final step of data pre-processing in machine learning, and it is a technique to standardize the independent variables to the data set in a specific range. So if data set is not in a scale, in a range, then you have to bring it using the Euclidean distance or some other means. Here we will use the standardizations method to our data sets using some library functions, sklearn, dot preprocessing, etc. Here we have done it, we can clearly see all things. So this is all about these things. So these are the theoretical parts, and we have given the clear concept of what is this regression, what is this classification, and for the implementations I will be explaining in the next video. Till then, goodbye. And if you do like this video, please do share with your friends, and also don't forget to subscribe so that the new videos can directly reach to you. Thank you for watching. Please take care of health. Have a good day.